Whenever we have four terms that we need to factor, and eventually, whenever we're factoring a trinomial, we're going to use a process we call factor by grouping. Factor by grouping for right now is going to have four terms. And what we're going to look at is we're going to factor the front two terms, and we're going to factor the back two terms separately. If we factor them and we can take a term out, we're looking for the binomials that are left over to match. If that's the case, we will then factor out that binomial to get to a factored version. So let's see what that looks like. So it's the same process each time, so let's just focus on that process of factoring and getting things to match. So factor the first two, factor the last two. So these two have a 2m squared in common. That leaves me with an m plus 4. The back two have a 9 in common, and that leaves me with an m plus 4. These both match, and that is the key. If you can get those two terms to match after you factored out, this process is going to work. So from here, I'm now taking this term and factoring out an m plus 4, and this term factoring out an m plus 4, just like factoring a GCF. So that comes out, and what's left now in the whole thing when we factored is 2m squared plus 9. So the m plus 4's come out as a factor. The leftovers are the 2m squared plus 9. There's our factored form. We have an answer. So let's watch that process again. First two, last two. First term has a 3x squared in common. I take out I'm left with a 2x plus 3. Now the second one, they don't have anything in common, but I'm just going to write a 1 on the outside. Why I want to do that is, look, now they both have a 2x plus 3. I'm going to factor that out of both terms. So that puts a 2x plus 3 on the outside. What I'm left with is 3x squared plus 1. Now, does this work? Is this actually work at factoring it? So the opposite of factoring is multiplication. So I'm going to take this and check my answer. 2x plus 3 and 3x squared plus 1. This gives me 6x to the third, 9x squared, 2x, and 3. And when I write them out, 6x to the third, 9x squared, 2x, and 3, so it even would have got back to the same answer. So we're going to practice this and make sure we understand that process of factor by grouping. So first two, last two. The first two look like they have maybe an 8. So let's go 8d squared. And even if we don't get the largest, greatest common factor and it doesn't match at first, we can still kind of work with it and make sure they do match. So 8d squared leaves me with 8d minus 5. Now, 24d and 15, they have a 3 in common, but I want it to look like this. So I'm going to take out a negative 3 because I want this to be a positive 8. So that becomes 8d minus 5. We look, both of them have 8d minus 5. Factor that out, and I'm left with, in this whole thing, if I factored it out, 8d squared minus 3. So my two factors are 8d minus 5 and 8d squared minus 3. Next problem. We look here, first two, last two. These 3 and 5 are not factorable. They're relatively prime to one another, but they have an x to the fourth in common. So that leaves me with 3x squared plus 5. Now I want this one to match, so I'm going to take out a negative 1, changes both of its signs, so it's now 3x squared plus 5. This factors out, 3x squared plus 5. The leftover terms are x to the fourth minus 1. Now, normally we would stop there and call that factored, but this is a difference of squares. So if we remember that from the previous time, we can split this to be x squared minus 1, x squared plus 1, which is now factored. We now have 3 factors. But wait, this is a perfect square, or this is a difference of squares. So this becomes x minus 1, x plus 1. This is the sum. You can't do difference of squares with that, so that one's finished. But now we have all 4 of these factors. So this is actually factored to be 3x squared plus 5. There's that one. X minus 1, x plus 1, and then x squared plus 1. So there's actually 4 factors in that one by breaking it down. We use factor by grouping and then also difference of squares, which we've seen before. So a few more. I'm going to take the first 2, last 2, take out a 5s squared from both of these, leaves me with 2s plus 5. So if it's going to work, it's going to match 2s plus 5. I'm going to take out a 4. That leaves me with 2s plus 5. 2s plus 5 is the common term. Factor that out. I'm left with 5s squared plus 4. Neither of those are going to factor anymore. We have our factored result. Next problem. Factor first 2, factor last 2. 2 and 5 are relatively prime, can't factor there, but I'm going to take out an x squared, and I have 2x plus 5. Negative 8 and negative 20, I'm going to take out a negative, let's do negative 4. That gives me a 2x plus 5. These match, so we're going to go 2x plus 5, factor that out. Left with x squared minus 4 here. Now x squared minus 4 should pop in and we think, oh, that is a difference of squares, which is going to become x minus 2, x plus 2. So our factors are 2x plus 5, x minus 2, x plus 2. Down on the next row, now we've gotten a little more numbers to it, and larger numbers, and we have to simplify it. Now before we do that, it's always good to go back and look at greatest common factor. 60, 72, 210, and 252 are not only divisible by 2, not only divisible by 3, but they're all divisible by 6. So 6 is a common factor they all have. So if I take out a 6, and actually an a squared also, because they all have at least that, I'm now left with 10a to the third minus 12a squared minus 35a plus 42. So now it's smaller numbers to deal with. And actually, I'm just going to bring that 6a squared, put it down here because I don't want to forget it. So first 2, I'm going to take out a 2a squared, and I'm left with 5a minus 6. The next one, 35 and 42, I'm thinking 7. So I'm going to take out a negative 7, and that leaves me with 5a minus 6. That's good. They match. So we're going to go 5a minus 6 and 2a squared minus 7. Now, even though this is an a squared, these are not perfect squares. It's not a difference of squares. Bring them all down to join the 6a squared already. 5a minus 6 and 2a squared minus 7 is my factored form. Now the last one we have is a little bit different, but it uses this idea that we take binomials and actually use them to factor. So I want to factor out a GCF of this whole expression without simplifying it, without multiplying out, because I don't want to multiply everything and have to work back. So if I look at this, let's think of a equals x minus 3 and b is x plus 2. So if I did that, I would actually replace things and say a times b minus b squared. And if I gave you that and said factor it, you'd be like, well, they both have a b in them, and that leaves me with a minus b. So if we do that here, we're saying is we're taking x plus 2 and taking it out of this term and this term. Don't think of them as binomials, just think of two values that are being multiplied together. So when I do that now, I'm going to take out an x plus 2 from both of them, and I'm left with x minus 3 minus x plus 2. The GCF, the greatest common factor they both have, is x plus 2. This one has one of them, this one has 2. So instead, I've taken that out and written my final answer.